Today we're going to continue solving our trig equations. We have a few additional examples for today. So these are the examples. For March 15th. Example 1. If we have the equation tangent of x sine x plus tangent of x, we want to rewrite this so that we can solve. What we're trying to do is to write it to where we can take factors and set them equal to 0 and solve. Hopefully we all see that these two terms have a common factor of tangent of x. We can factor out the tangent of x. And when we do, we have tangent of x times sine of x plus, when we do tangent divided by tangent, we're left with a 1 here. Now this is equal to 0. Now we take each of the individual factors, set them equal to 0, and solve. So let's think about where tangent has a value of 0. And we'll think about where a sine has a value of, well, what would we do to solve this? We would subtract 1 from both sides. And when we do, we get sine equal to -1. Where does sine have a value of -1? So tangent has a value of 0, where? At 0 and at pi. So it also, if it has a value of 0 at 0, it also has a value of 0 at 2 pi. Sine has a value of -1 at 3 pi over 2. And just like yesterday, we're going to list all the values between 0 and 2 pi. Okay, there's example 1. Example 2. Secant x sine x plus sine x equals 0. This one is quite similar to the last. Hopefully we can all see it has a common factor of sine. So we factor out sine, and we are left with secant x plus 1 is equal to 0. So we're looking at the two factors. We set sine of x equal to 0. We set secant plus 1 equal to 0. So where is sine 0? Sine is 0 at 0, at pi, and at 2 pi. Then we solve this. So here we're looking for, where is secant -1? Where is the reciprocal of the cosine? -1. Well, that is still, the reciprocal of -1 is -1. So think about the unit circle. Where is the x value -1? That occurs at pi, but we already have pi listed, so these are our solutions. Example 3. We have sine squared x minus 2 sine x plus 1 equal to 0. How will this factor? Hopefully we can see this is a perfect square. This is a perfect square. So let's try to factor it into square root sine of the middle. Write it as a binomial squared. We're taking this perfect square trinomial and rewriting it as a binomial squared. Now, if you didn't see that, you certainly could have written it as sine of x minus 1 times sine of x minus 1. We are factoring this trinomial. So, basically all we have to do is set one of these equal to 0, sine of x minus 1 equal to 0, and solve. So where is sine of x equal to 1? Where is the y value 1 on the unit circle? That occurs at pi over 2. That's our solution. Okay, next problem. Number 4. 2 cosine squared x equals cosine of x. Alright, currently this one is not set equal to 0. To be able to look at the factors and set them equal to 0, that's what we have to do first, is take the original equation and set it equal to 0. So we'll move the cosine to the other side, and it becomes negative. Now we can see that we have a common factor of cosine. So we factor it out, and we're left with 2 cosine minus 1 equal to 0. We take each of the factors, set them equal to 0, and solve. So this one we're done. This one we're going to move the 1 over, divide by 2, and we're thinking about where cosine equals 1/2. So where is cosine equal to 0? That occurs at pi over 2 and 3 pi over 2. Where does cosine equal positive 1/2? At pi over 3 and 5 pi over 3. Okay, number 5. We're going to let number 5 be a you try, and I'm going to give you a few moments before I show you how it works. This is 4 sine cubed x equals 3 sine of x. Take a moment, see what you can do.
It's super easy. The people, I would have gotten it right, but I had Thomas Wallace and Adam Smith switch, and so I had them right, and then I switched, and then I got them both wrong. And then, so I got 2 questions off of that, and then I clicked on the wrong one for one of them, so I would have gotten 6.
Okay, what we're going to do is move everything to one side. Factor out the common factor. Set each factor equal to 0 and solve. So we're thinking about where sine of x is equal to 0 and 4 sine squared x minus 3 equal to 0. Alright, the one on the right takes a little more work, so we're going to move our constant over. Divide by the 4. Take the square root. And when we take the square root, we get plus or minus. So we have sine of x is either positive or negative square root of 3 over, what is the square root of 4? 2. So these are the things we're looking for. Where is sine 0? Sine is 0 at 0, pi, and 2 pi. I think we've already done that one. Where is sine equal to positive square root of 3 over 2? It's positive square root of 3 over 2 at pi over 3 and 2 pi over 3. Where is it negative square root of 3 over 2? That's at 4 pi over 3 and 5 pi over 3. So those are the solutions. Number 6. Number 6, we have cosine squared x equals 3 minus 2 cosine x. First thing we want to do is set it equal to 0. So we're going to move it over. So this becomes a positive 2 cosine of x and a negative 3. Okay, now we're going to factor. And we're going to factor the way we always have. What can you multiply to get negative 3 that you can add to get positive 2? Well, that is positive 3 and negative 1. So we need a cosine x and a cosine x. So cosine x plus 3 equals 0, or cosine x minus 1 equals 0. So here we get cosine x equals negative 3. Here we get cosine x equals 1. All right, where is the cosine value of x equal to negative 3? It's not. The greatest it can be is positive 1. The smallest it can be is negative 1. So there is no solution here. All right, where is cosine positive 1? This occurs at x equals 0, which is the same as 2 pi. And those are our solutions that occur between 0 and 2 pi. A few more examples and then we'll be done. Number 7, we have 2 sine squared x plus cosine x equals 1. This one takes a little more work because we have sine and cosine in this problem. We want to rewrite these in terms of one or the other. We know that sine squared x plus cosine squared x equals 1. So let's use this conversion. So sine squared is 1 minus cosine squared x. And then we'd have it all in terms of cosine x. So we're going to substitute that in. Sine is 1 minus cosine squared x. And move the 1 over. We'll distribute this 2. And so this would give us, you know what, I think I'm going to move everything back over to the other side because that will make my squared term positive. I like that a little better. So we move it over, it becomes positive. This will become a negative cosine, and this 2 with this negative 1 is a positive 1 on the left side. So when we move it to the right side, it is negative 1. So now we're going to think about how this can factor. Okay, there's only one way to multiply and get 1. It's 1 and 1. So we know these have to be 1. Okay, now, how do we multiply to get 2? There's only one way to do that. 2 and 1. Now we just have to determine what the signs need to be. Okay, we want a negative in the middle. So since we want a negative there, we'll put a negative here. That makes a negative 2. And then we'll put a positive here to make the positive 1. So what we have is 0 equal to 2 cosine plus 1, and 0 equal to cosine x minus 1. So this gives us negative 1 equals 2 cosine x. So divide by 2 and we get negative 1/2 equals cosine x. Or add on the second one, we add 1 to both sides and we get 1 equals cosine x. So let's think about this. Where is the x value, negative 1/2, on the unit circle? It is negative 1/2 at 2 pi over 3 and 4 pi over 3. Where is the x value? 1 at 0 and 2 pi. We've done that one several times now. Okay. I have 2 more examples, and then we are done. Number 8. Sine of 2x plus cosine of x equals 0. This is the double angle formula for sine, so we're going to substitute in what we know. Now, does everybody see already that it's going to have a common factor of cosine? So we're going to take out this common factor of cosine x, and we're left with 2 sine x plus 1 equal to 0. So cosine x equals 0, and 2 sine x plus 1 equals 0. So 2 sine x equals negative 1. So sine x equals negative 1/2. So where is cosine 0? At 0 and 2 pi. Where is sine? Negative 1/2. Sine is negative 1/2. Whoops. Hold on. Cosine is not 0 at 0 and 2 pi. Let's try this again. Where is cosine 0? That is at pi and at 3 pi over 2. Pi over 2 and 3 pi over 2. And sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. Okay, so once again, I was not thinking cosine, I was thinking sine here. Cosine is 0 at pi over 2 and 3 pi over 2. And then sine is equal to negative 1/2 at 7 pi over 6 and 11 pi over 6. Last example, number 9. We have 4 sine x cosine x plus 2 sine x minus 2 cosine x minus 1 equal to 0. This is one of those 4-term grouping problems. We're going to group the first two. We're going to group the second two. What do the first two have in common? A 2 and a sine x.
Oh my gosh, one person. Attach these three.
Okay, now we want the second one to match. What do we need to factor out of this so that we're left with 2 cosine plus 1? A negative 1. So this is 2 cosine x plus 1 times 2 sine x minus 1 equals 0. Take each factor, set it equal to 0, and solve. So we get cosine x equals negative 1/2, and sine x equals positive 1/2. And where does this occur? Sine is 1/2 at pi over 6 and 5 pi over 6. Cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3. All right, now you need to try the problems out of your book.